Okay, so I went ahead and actually made the homework for today due on Sunday, right? So for those of you who are going to study for the test on Friday, you can continue to do so, okay, without having to do the homework. All right. Okay. So how do we sample well? So we talked about some ways not to sample. We talked about convenient sampling, talked about volunteer sampling, that kind of stuff. So to random sampling, okay, so on page 225 bottom there, it says random sampling involves a chance process to determine which members of a population are included in the sample. So it has to include a chance sample. Not only does it have to do that, if you flip the page, when you do a simple random sample, an SRS, what we call an SRS, you do a simple random sample of size n is chosen in such a way that every group of n individuals in the population has an equal chance to be selected in the sample, okay? So not only do you have to use a chance sample, everybody's chance of being selected to the sample has to be the same, okay? All right, so where are we at? Let's say that I had 10 people and I'm trying to choose a person who's going to or a chairman of out of the 10 people, okay? But I'm going to do this in a random way. So how would you do that? How can I possibly do this? What were some ways that you guys would do it? What would be the easiest way to do it? What would be the old-fashioned way to do it?
I'll just think of like a bingo machine.
Okay, the bingo machine, right? So you would have 10 people. You would put their names on one piece of paper, right? Throw them in a hat. Do this to the hat, right? And then you would pick a name out, right? Isn't that the old-fashioned way, right? That would be the most, because everybody would have the same equal chance, right? And it'd be truly random, right? So that'll be one way. What will be another way? What will be another way using your calculator? I'll give you a hint here.
Isn't there like a random number generator?
Correct. You could use a random integer generator, right? Randint, right? It's a random integer generator. So you can use a random number generator, and you would go 1 through 10. You would label each number. Each person would have a number, right? And then you would go press the calculator and say, give me a random number between 1 and 10. And it's voila, it's number 5. Then you would find out who had number 5, and that person would win. Okay, so that's a truly, right, equal chance, right, random, correct? Okay, so there's actually 3 ways. So we just described the 2 of them. Okay, so then we'll talk about the other one. Okay, so how to choose a simple random sample. There's a green box there, page 226. Label, give each individual in the population a distinct numerical label from 1 to n, where n is the number of individuals in the population. Randomize, use a random number generator to obtain n different integers from 1 to n. So in other words, if I have 100 people, I have 100, the population is 100, I'm trying to do a random sample of 10, I would label each person 1 through 100, and then do a random number generator between 1 and 100, and to get the first 10, right? So you randomize, and then you would select, right? Okay, so that would be the second way that we talked about. That was the second way, right? So underneath, on the bottom of 226, it shows you how to choose an SRS, okay? So you would go to math, prob, and so that's probability, right? If you go to probability, there's a randint, and then you would use that, okay? Now the third way to do this is to use table D. Well, what the heck is table D? The table D is the table that's in the back of your book. The very back of your book, if you go to the very back of your book, there's a table D there. So let's see if we can find table D. And so where am I at? Table D. Okay, so table D. Did everybody find table D? It's on page T-5. T-5, there's line 101 through line 150. And you have 5-digit numbers going across. You have 1, 2, 3, 4, 5, 6, 7, 8. So you have 40 numbers in each row, 40 numbers in each row, and those are just random numbers. Okay, and you use that. Okay, so how would you use that? So the way you would use that is that if you want, let's say that we're going back to our number over here, we're trying to generate a random number between 1 through 100. Okay, what's the first 5 numbers on table D? Can anybody tell me? Read it off. Kat, what do you got? Kat?
I can't find it.
T-5. Kyle, did you find it?
Yeah, 19223.
19223, right? So your first numbers are 19223. So you have 19223. Then the next numbers are what, Matt?
95034.
95034, okay, right? So you want numbers from between 1 through 100, okay? So this is, okay, so pay close attention, okay? You can't go 1 through 100 here, right? The reason why you can't go 1 through 100 is because this is actually 003, right? Or you could do it this way, but then you would have to do 3-digit numbers, right? But you want you want to get 10 out of 100. So the way you're gonna go is from 0 to 99. If you go from 0 to 99, you can play with 2-digit numbers, right? So each one of these are gonna be 2-digit numbers. So you're gonna go from here. The first number is 19. Second number is 22. Third number is 39, 50, 34, and so on and so forth. You understand how that works? So this is how you would get the first 10 2-digit numbers, right? And hopefully you would get something like 06, so that way it would work when you'd have to, if you only had to see, if you did 6, I did number 6. Okay. So that's how you would generate a 2-digit number, random 2-digit number, using the table D. Okay. You don't have to start at row on the very top row, right? 101. You can use whichever row you want. You can go to row 125. If I go to run 125, what's the first 5-digit, 5 numbers there? What did you get? What did you see?
96746.
Yeah, so 96746. 12149. So the first 5 numbers would be 96, 74, 61, 21, 49. You see how that works? Okay, so this is how you would, so you use that table, you're using that table as a random integer generator, really, random number generator is what you're doing. Okay, so again, this is truly by chance, and everybody's gonna have or get the same probability of being picked to your sample, okay? So let's go back to the convenience sample. Let's talk about the convenience sample. If we did the convenience sample, can you see why, if I just did a convenience sample, the people that in my vicinity are the only ones that I'm gonna pick, and the people who are not in my vicinity are never going to be picked. Therefore, the people who are not in my vicinity have a 0% chance of being picked, and the people who are in my vicinity, who are convenient to me, are going to have a much better chance of being picked. Therefore, it's not an SRS. It is not a simple random sample because each person does not have the same probability of being picked. Okay. Volunteer is the same way, right? If you do not volunteer, you have 0% chance of being picked, right? Whereas the people who volunteer have 100% chance or a greater chance of being picked, right? Therefore, it is not a simple random sample, okay? So the three different, so let's review. The three different ways to do a simple random sample is the hack method, then the random number generator in your calculator, and then the table D. Okay, the three different kinds, right? Three different kinds, right? And you guys, okay, so that's it. And so if you go to the example on attendance audit, blah, blah, blah. Each year, the DOE randomly selects 3 schools from each district and conducts a detailed audit of their attendance records. A, describe how to use a table of random digits to select an SRS of 3 schools from the list of 19 schools. Okay, so you would do that using what? So we're going to use the table D, right? We're using the table D. So you're going to assign each school a number, right? From 01 to 19, from 01 to 19. And we're going to do the same thing we did over here, right? We're going to do, they want to use table D. Okay, so you would do that, right? And then you would do table D, and you would go from here. What would you do if you had a number that was 34 or 74 or anything that's between, not between 01 and 19? You would just disregard it, right? You move on to the next one until you get 3 of them that are underneath 19, okay? Or is it 17 or is it 19? 19, okay? Right? So that's how you do it. So use the random digits here to choose a sample. So the first number here is going to be 62. You don't use that. Then you go to number 8. So number 8 would have been what? 1, 2, 3, 4, 5, 6, 7. Harrelson Elementary, it looks like. All right. And then after 8, you get 16, which looks like would have been Prince Elementary. And then after 16, you get 48, you disregard that. And then you get 16 again. Oh, I already did 16, so you have to disregard it, right? 87, disregard that. 37, disregard that. 40, disregard that. 95, disregard that. Then you get 17. Okay, so you got 3 of them, right? And that's how you would use that. Okay, other random sampling methods. Okay, so these are somewhat important. They come up, just enough that you have to pay attention to them. Okay, we're going to do a strata or a stratified random sample. We're going to do what we call a stratified random sample. So if I had let's say that I had a river flowing here. I had a river flowing here, and on the land right next to it, I planted corn. Okay, so I planted corn. And what I'm trying to find out is the yield of the corn, right? I'm trying to find the yield of the corn, okay? So what a stratified sample is this. Corn, generally, if you get more water, you get a better yield, right? So in other words, the rows that are closer to the water are going to get a higher yield. So you'd have a higher yield, less higher, less higher, less higher, least highest, right? You're gonna get the smallest or the worst yield out of this, right? So you could do a random sample. You could do a simple random sample by saying, well, 1, 2, 3, 4, 5, 6, 7, 8. And we'll label this 1, 2, 3, 4, 5. So this would be 11, 12, 13, 14, 15, 16, 17, 18, 21, 22, or whatever. Or you can actually just say, I'm going to call this 1, 2, 3, and label them all the way through, right? And you would, out of the 40 of them, you would pick, let's say, I don't know, 4. You can randomly, by using your calculator, you can pick out the first 4 or 5 or how many samples you want, right? That's one way to do it, okay? Another way to do it is you would actually take this whole cluster, well, this whole row, and call this one of the stratas. This is a strata. Okay, you would use this as strata, and you would do that. And the reason why you would do that is what? Because the corn yield within the strata are going to be pretty much the same, right? So you can go ahead and call that one data, and then you would take like 3 of these, 1, 2, 3 separate stratas, and you would go ahead and take the average of that. Okay? So, what would the green book, the definition of the green box says, strata are groups of individuals in a population who share characteristics thought to be associated with the variables being measured. Stratified random sample selects a sample by choosing an SRS from each stratum and combining the SRSs into one overall sample. Okay, so let's go to that activity there on the sunflowers, okay? On the activity on the sunflowers. So a British farmer grows sunflowers for making sunflower oil. Her field is arranged in a grid pattern with 10 rows and 10 columns. So we're gonna go ahead and do that, and then it says label table D or technology to take a simple random sample of 10 grid squares. So that's the first thing that I talked about. So you would simply just label them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way through 100, and you would pick 10. Okay, so that would be not a stratified sample, right? That's just a regular simple random sample. Okay. This time in number 2, it says select a stratified random sample using the rows as a strata. Use table D or technology to randomly select 1 square from each horizontal row. So each of these you would pick 1, right? So you go 1 through, so the book has 1, 2, all the way up to 10, all the way up to 10, right? And you would pick 1, right? One of these from 1 to 10. You would pick 1 here, 1 here, 1 here, 1 here, and 1 here, right? Okay. And then you could do that. Then take a stratified random sample using the columns as strata. If you use the columns as strata, you can go using the columns as strata, right? So this was the row, and this was the column, okay? Which one do you think is going to be a better data? Just take a guess. Your teacher will provide the actual number, blah, 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 blah. Okay, so if you do this, what you end up finding is this. When you do a stratified in each row versus each column, okay, you're gonna have better representation using each row because each row has the same characteristics. So this is one of the things that you always have to think about when I talk about a stratified sample. A strata has same characteristic within each strata, different characteristics without. Okay, so within each strata, you want to have the same characteristic, and each strata, you want to have different characteristics. If you did the stratas this way, okay, that does not make sense because now each strata really does not give you any true characteristic. There is no shared characteristic of a column strata here, right? Because each one is going to be different, right? If you had, let's say, I don't know what the yield here was, 50, 40, 30, 25, and 18. Okay, if it was like it's 32 or something like this, there is no shared characteristic here. But if you go across here, you're probably going to find that it's going to be 51, 47, 49, 50, 52, 53, something like that. Whereas they're all kind of the same. They're going to be pretty high, and down here are going to be pretty low. Okay, so each, you wanna, when you're selecting stratas, you want them to make sure that they are same within the strata, but different without. I mean, in the out, different stratas have to have different characteristics. Okay. So flip the page, and then we have something what's called a clusters or cluster sampling. Okay. I'm going to read this to you with a caveat. Okay. You can read this. I will read this. Let's just read it first. Let's go read it first. A cluster is a group of individuals in the population that are located near each other. Cluster sampling selects a sample by randomly choosing clusters and including each member of the selected cluster as a sample. What does this sound like? Of all the things that we learned today, what does it sound like? Doesn't it sound like convenience sampling? Right, because you're selecting a cluster, the whole cluster that people that are within or close to whatever cluster that you're going to pick. Right? So this is something you have to take very carefully because there are very, very few things that you are allowed to use a cluster sample. Okay. So if you think about it, you're going to go ahead and let's say that I have, again, let's say that I have something that looks like this, okay? And I'm going to make the assumption that all of these little plots or all of these little squares are going to have essentially the same yield. Now, if I make that assumption, I can go ahead and pick this guy and then something close to that and close to that and call it a cluster sample. And I can sample one of each, one of each, one of each, and then say, I'm done. And the problem is there are very, very few things that you can do this with. There are very, very few things that you can assume that they're all going to have, they're going to be homogeneous, basically, okay? It's very hard to make that assumption. Therefore, it's very rare that you will ever use a cluster sample. Just be aware that there is a thing called a cluster sample and how we do it, okay? So if you look at the cluster sample, it says what? Cluster is a group of individuals in the population that are located near each other. Cluster sampling selects a sample by randomly choosing clusters and including each member of the selected clusters in the sample. All right? So just, that's about enough here you need to know when it comes to clusters, okay? And let's see where we at. Blah, 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 not that. Okay, we're done for the day. We are done for the day.